ProtoTRAK, it's not your father's ProtoTRAK. So this is our ProtoTRAK RX Demo Box. It says RMX here, but I can also show you the RLX lathe control. The first thing I want to point out about the demo box is it's the exact same as the control that you would find on a milling machine or the same controls you would find on a lathe. If you look over here, you have a series of hard keys. The hard keys are very limited. There's an X-axis, a Y-axis, and a Z-axis button. Inkset and abset give you the ability to enter those are your enter keys on a ProtoTRAK. If you hit inkset, you're entering a dimension that's referenced incrementally from the last point program. If you enter and hit abset, you're entering a dimension that's referenced from absolute zero. Engineers mix incremental and absolute dimensions all the time, but most CNC controls force you to program everything incrementally or everything is absolute zero, which means the machinist now has to take time to recalculate dimensions. When in truth, they may be using an incremental dimension because the hole-to-hole location is what's really important from a tolerance standpoint. So if you can draw using both, why shouldn't you be able to program using both? And ProtoTRAK has always understood that and has for the last 40 years. We got buttons here to enter dimensions. We assume a whole number. We assume plus, just like every calculator and computer you use. There's a plus-minus key if you need negative. There's a decimal point for decimals. Down at the bottom, there's a back button to take you back one screen at a time, and restore lets you start all over again. So there's only 19 hard keys that you need to hunt and peck through. Many CNC machines have 168 buttons or more. Giving you more buttons doesn't give you more capacity. What it does is give you more complexity. And so by limiting the number of buttons to hunt and peck through, somebody can learn this control and learn how to navigate it much quicker. We have a few other keys across the bottom. Go starts it, stop stops it. Spindle forward, reverse, and stop. Fine and coarse allows you to control the manual feed rate of any electronic hand wheel. You can turn accessories on and off, and here's where you hit your power button. Other than that, there's just not a lot of buttons to look at. What's made ProtoTRAK very easy yet very powerful, going back to 1985, was simple to use menus. In '92, we added the addition of soft keys. So by using soft keys, we can give you a lot of capability with really a limited number of buttons to hunt and peck through. Looking at the soft keys we have here, shutdown is somewhat obvious. You wouldn't see this on a mill or a lathe, but on a demo box or on the offline software, you have the ability to toggle from a lathe control to a mill control. So if you were to buy our offline software, you get 2-axis milling, 3-axis milling, 4-axis milling, and turning all in one software package. Demo box allows us to come in, show you what the control do, and allows you to ask questions, something that you can't do if you're simply watching a videotape. Two soft keys that you may not have seen before if you had earlier generations of ProtoTRAKs. One is the Watch Me button. This is a new generation of ProtoTRAK. It's got soft keys. You'll notice it says modes here, but I don't have the modes of operation that I had before. If you're trying to figure out how to get started, if you hit Watch Me, what you're going to get is a series of videos that Tracking Pat is going to come on and explain how to maneuver the control. Every control comes with a headset that you can plug in the back, so if you're out in the shop, you have one-on-one with Pat. If you're doing it in front of a group, we can plug in a speaker and allow everybody to hear. The button I'm even more excited about is what's new. We have always allowed people to get the latest version of software by going to our website. You can look and see what you have. If there's something newer, you download it, you put it into the control, and it will update itself. It takes a matter of minutes. In the old days, if you were updating the software and you wondered what was going on, there'd be a Word document that you could download and read. If we introduced a new feature that you wanted to know how it worked, you could go then to on our website and find the manual, download the latest PDF and read about it. Or you could pick up the phone and you could call the person that sold it to you and say, tell me what's going on that's new. Now if you hit what's new, Tracking Pat's going to come on and he's going to tell you what we've added into the control since the last update. And so we bring the message right to you. Check system. Check system gives me the mode buttons that I've been used to seeing since 1992. They used to be across the bottom. We moved them to the side a few years ago. They're still right here. DRO is how do you use it manually with a digital readout. Program is how do you write a program. Edit is, it allows more global editing. Setup is setting up a program to run. Run is running the program that you've set up. Program in out is putting the program into memory or taking the program out of memory. We allow you to save it onto a network. It's a standard feature. Or you can save to a USB drive, which means your program storage will be limited to the size of the thumb drive that you want to use. But before we get into the modes of operation, let's talk about some new soft keys that have been added to the left side. The left side soft keys are fly-out windows. You press it once, a window flies out, you can do something with it, you press it again, it flies back in. If I hit status, I can see right here what version of software I'm running. I can go to the website and see if there's something later. It tells me that I've booted up in inches. If I wanted to, I could change that to millimeters right now. And by the way, if you have a print that happens to have both metric and inch dimensions, that's okay. That doesn't stop us. You can toggle back and forth as you're going. Recently, I did a demo which was all in inches, but it had a metric thread on. So we programmed the part, we flipped it to metric, we put in that it was M20 by 1.5, but then the length was dimensioned in inches for whatever reason. We just flipped back to inches and put in the length. You can have 3-axis, you can have 2-axis. So we give you the ability to say, how do you want to use and write your program today? It also shows you down here any options that may be turned on. For my demo box, I have virtually everything on right now. We've added a tool table. Many years ago, we would save the diameter but not the length of the tool. There was no guarantee that the program you pulled up from a year ago still had tool number 1 the same length and tool number 2 the same length. People with tool changers and other levels of automation have gotten used to using tools over and over again. So now, when you enter the tools into the ProtoTRAK, you can save them to a library and you have them for later use. You can still go through writing your program using tool 1, tool 2, tool 3, tool 4, and then you can come over here and select from the menu as to what tool is going to be tool number 1. And if you're on one of our TMCs that happens to have a tool changer, you can also tell the control where that tool is going to reside in the tool changer. So you're not locked into everything being 1, 2, 3, 4, and in the tool changer is 1, 2, 3, 4. EPA. Sounds like a dangerous 3 letters in a machine shop, but here it's pretty exciting. It's called Enhanced ProtoTRAK Assistant. We are going to bring to you an abridged version of the manual to show you how to do something you may have in question, up to and including a video from Tracking Pat that shows you what to do. So say you had to thread mill something and you remembered that the apps guy or the salesperson had told you could thread mill, but it's been 2 years and you're scratching your head wondering what to do. If you go to EPA and you pull up thread mill, it's going to walk you through what you would find in the manual in a very Reader's Digest type way, up to and including a video of Tracking Pat showing you how to thread mill. Math help goes back 40 years. It's calculating a dimension that's not on the drawing that you need. Defaults are really exciting. Defaults allow you to set up the control to follow your style of machining. Machinists are real artists. If you give 3 machinists the same print and the same material and ask them to make the part, all 3 of them can make you a good part, but they may all attack it in a different way. With defaults, I can set up the parameters that I like, and what it does is it eliminates mundane button pushes. For instance, I like to use a 5/1000 finish cut when I'm doing pocketing. Well, I can set this up and say that my finish cut is going to be 5/1000. Now, every time that a finish cut is an option while you're programming, rather than having to hit 0.005 set, I simply hit set and it transfers the data. So I've taken 5 button pushes and moved it into 1. Every time I have to hit fewer buttons, I'm making it a little less complex. If I decide that I'd like to have 10/1000 finish cut for what I'm doing, not a problem. I can still hit 0.01 set, but the default will come up to my style of machining. Now, if Chris is sitting here and he wants to run a machine and he likes 10/1000 finish cut, he's going to set the default to that for him. I like to rapid the tool down 100,000ths above the part. Mike over here might like to rapid to 50,000 above the part. Well, if he does that, anytime it asks for a Z rapid, it's going to show up as 0.05. He just hits set. Rather than having to hit 0.05 set, 4 buttons becomes 1. So machinists can come through here and they can make this customized to the way that they're going to make parts. We can even go one step further. Rocky here might be a skilled machinist that has to cut aluminum, and he has to cut stainless steel, and he has to cut tool steel. So he can set up the parameters in his defaults around the type of material that he's using. So if he's got a gummy aluminum that needs 20,000ths to give you a decent finish, he's going to set that up. And now if Rocky is training an apprentice and he says, hey, this material, call up Rocky-aluminum, he will have defaults set up around the type of material that they are using. I got an onboard keyboard, but I got plenty of USB ports too, so if you'd like to plug a keyboard in and type, you're welcome to do that. I also have an onboard calculator that you can use. Something that's new in the ProtoTRAK is while you're programming, you need to use a calculator. Rather than writing down the dimension and typing it in later, we have an inkset and abset button that lets you transfer the information right from your ProtoTRAK calculator right into your program. Let's talk about some of the capabilities. ProtoTRAKs can be used manually. Even on our machining centers, we put hand wheels that allow a machinist to stand up and crank handles. There's a hand wheel so that you can move Z. You can drill holes just like you would on a ram turret knee type mill, commonly called a Bridgeport, on a TMC or a DPM. If I hit DRO, I get a large 3-axis display. You'll note that my overrides are here, so instead of having to go beep, beep, beep and raising and lowering your feed rates to 5% or 10% increments or your spindle speed at 5% increments, I can simply reach over here and speed it up or speed it down by turning the dial. I've got some soft keys along the bottom. If I go in and call up a tool number, it'll change my Z0 to reference the bottom of the tool, because once you've put tools in your library, it knows the relationship of one tool to another. I still have the jog button. If you've never used a ProtoTRAK before, if you hit jog and I press the X-axis, it starts to move the table along. I change directions and come back the other way. Little things like indicating in a vise go from a few minutes to a minute or two. Centering is new. So if I hit center, I get line center or I get arc center. Well, if I chose line center, I can take my edge finder. I can come down and find the left side of the part, hit set, get that out of the way, move over to this side, hit this side of the part, hit set, get out of the way, press center, and it'll go find the center of the part. And if that's going to be my 0, I zero out X. I do the same thing in Y, go to the center, I have found center. The feature I like really a lot more about center, though, is circle center. One of the things that can take time on finding a center of a bore is setting up an indicator to tram in a bore. Well, now with this, I can have a circle. I can take my edge finder. I can hit 3 parts in a circle, say go to center it finds, because 3 points defines a circle. And so little things like setting up a part that's got a round bore to work from become just much simpler. And I still have the smart power feed that allows me to move the x-axis or the y-axis or the z-axis a specific distance. I can also move them in tandem, so I can move x and y and generate an angle without swiveling a vise. I can move x and z, I can move y and z. I can move all 3 axes, so when people tell you that a ProtoTRAK is only two and a half axis, if I can move all 3 axes at one time, I guarantee you I have a 3-axis control. And if you don't believe that, when you see the button that says helix or the button that says thread mill, you know that I've got to be able to move all 3 axes simultaneously. You might notice that there's no longer a mode button out here. You know, from 92 to 2018, if you wanted to go from the digital readout mode to the program mode, you had to mode out a DRO and then push program to go in. Today with soft keys, I can just go from one mode to the other without moding out. Program names, still, the limit's going to be the Windows number, which I believe is 42 characters. I can still scale from 10% to 10 times the size of the part. If you're doing mold work and you need 3% shrinkage, if I make that 0.97 or 1.03, it will make it 3% bigger or smaller without me having to do any recalculating. If you want to make an 1/8 inch scale size part, I can simply change that 1 to 1.25 or 0.125. Might have to change the cutter size, but now I've got 1/8 inch scale. I've got multiple fixture offsets up to 20. For the G code guys, this would be your G54, G55, G56. And from down here, I can choose to go to the beginning. My programming choices, a position move lets me rapid somewhere in X and Y location, oftentimes for clearance. I can drill or tap holes, I can drill or tap bolt circles, I can mill straight lines, I can mill curved lines with an arc. A profile allows me to combine mill and arcs to generate some sort of profile. I have a can cycle for face milling to clear off the top of a part. Pocketing is very similar to profile. I can do circles and I can do rectangles and I can do irregular shape. Just a pocket removes all the material. A profile walks around the perimeter. If I go into pockets, you'll also see that I can leave islands standing in a pocket. And unlike previous generations where it was one island in one pocket, now as many islands as you can fit in the pocket is how many islands you can have. I still have subroutine and copy so that I can repeat, rotate, or mirror image anything I'm doing, plus a couple other choices. And I've got helix, engrave, thread, the ability to pause and clear off as additional software that lets you program geometry that you want to leave standing in a mesa, tell it what the outside material looks like, and it figures out how to remove everything for you. But let's just do something basic. If I wanted to drill a hole, I give you 4 choices now. If I select drill, I'm going to allow you to peck drill, and you can select whether you want it to be variable pecking or fixed pecking or chip break just to get rid of the chip. I have a can cycle for feeding a boring bar in and back out. I have the ability to go back and tap any holes that have been drilled. And I have helical drills, so I can open up a bigger hole with a smaller tool, and I can even have it come across and finish the floor so that I have a nice bottom finish. Let's just select drill. I give it an X location. I give it a Y location. You can see my default is for 100 thousandths for my rapid. I tell it how deep I want it to go. Number of variable pecks, let's pick 4. But you know, maybe I want to change the way that pecks. And it seems to me that used to be service code 33. I don't quite remember. But if I hit options, I can come right here and I can change the way this is going to peck on this one specific event. Doesn't change my defaults. Give it some spindle speed, give it some feed rate, and a tool number. And you can see it's drawing the part right as I go. I no longer need a look button. And if you're missing the chance to see 2 events at a time, I can still do that. It just makes my drawing a little smaller. If you want the drawing to be full screen, I can drag it all the way across. It's a touch screen. Let's come back to event 1 and let's go explore something under options. It's called multiple holes. Oftentimes in a job shop, you're faced with the same size hole, the same depth, so you're going to use the same speeds and feeds, but they're random hole locations. They're not linear, so you don't have the advantage of using a repeat. They're not on a circular pattern, so I can't use rotate. They are just scattered across the part. Well, if I turn on multiple holes, I can enter another X and Y location, and I can enter another X and Y location, and I can enter another X and Y location, and I can enter another X and Y location. And when I'm all done and say complete, you can see that it has written more events with the new X and Y locations and carried everything over for me. So we've tried to simplify a really simple job that's a lot of mundane button pushes when you're using a typical CNC control. Now, the second thing is, maybe these are drilled and tapped holes. Well, now I got to go back and select drill, and I'm going to change this now to tap, and I'm going to re-enter the X and Y dimensions with the Z information for tapping. But we also realized that almost every tapped hole got drilled first, so rather than have to do that, we now give you under copy the ability to drill to tap. And so I can say, take all those holes that you just drilled, which was event 1 through 5, wrap it down somewhere high enough to clear the tap, tell it how deep you want to go, put in the pitch. Pitch is 1 divided by number of threads per inch. So if it was 1/4 holes, 1 divided by 20 would be 0.05. Give it some spindle speed and a tool number, and now all those holes are programmed. We could have taken 50 holes, copied, drill to tap, all 50 holes would be ready to go. If we go over to our tool table, what tools do I want to use? Well, I said 1/4, so I probably want to use my number 7 drill. I'll make that tool 1, and I want a 1/4 tap, which happens to be right here, and I'll say, hey, that's tool 2. And you see that it's populated itself there. And now I'm ready to go find my 0 and make my part. Let's get out of this. We're going to go erase the program. Let's talk about doing something a little bit more complicated. And many people are used to seeing a part that we affectionately call the ballpark. It's called the ballpark because it looks like a ballpark. It's been in our literature for 40 years. One of the things that I'd like to point out about it is people will comment that they aren't going to make this shape on a manual mill anymore. So this is something I would put on my CNCs. But the setup and prepare for this to make 1 or 2 parts is a lengthy operation. If I want to program the ballpark here, I'm going to tell it I'm going to do a bolt hole pattern. I'm going to drill those holes. There's 5 holes in the pattern. I'm going to make the center of my part 0, 0. My default says I'm going to wrap it 100 above. I'm going to go down to a depth of 400 thousandths to get the drill through. I'm going to tell it that the radius from the bolt circle is 1.25 inches. I'm going to tell it that the angle to the first hole is 45 degrees. Now it'll know 5 holes are 72 degrees apart. It's going to spot the first hole 45 degrees off 3 o'clock. It'll put the second hole at 117, the third at 189. ProtoTRAK does all the math for you. Tell it how many times you want it to peck. Give it some spindle speed. Give it some feed rate. Give it a tool number. There's your bolt circle. Part's got a counter bore in the center, and the counter bore is a 750 radius, 1.5" diameter. I'm probably not going to put a 1/2" end mill in there and try to plunge it. That's what we would call a pocket. I get new choices: circle, rectangular, irregular shape. This is a circle pocket. The center of that pocket is 0, 0. Maybe I want to wrap it down 50 versus 100,000, so I'm going to change it this time. Tell it how deep to go off my drawing. Give it the radius, 0.75. Defaults to counterclockwise. I want a climb mill, so I'll just set, rather than having to hit 1 for clockwise, 2 for counterclockwise, I have a default. I have a default for the depth of pass. There's my finish cut. I'm going to give it some spindle speed, some finish spindle speed, some feed rate, tool number, there's my circle. I come over to my tool table. Why lose track? I want to drill the hole. Let's this time use my 3/8 inch drill. We'll call that tool 1. I'm going to use my 1/2" end mill and call that tool 2. And my tools are set up. Now I got this outside profile. And if you'd seen the Ballpark in the first 40 years, you would have seen a theoretical intersection point, which really is the intersection point. It's not theoretical because it's the actual intersection point of these two lines out here. And we gave you a dimension that says, hey, come out 3.064 and you come up 0.045, and then you tell it this radius is an 841 corner radius or connecting radius, and it would generate that blend radius for you. We've redrawn this into the modern era, and now we're going to define the center of the 841 radius with an X and Y dimension, because that would be typically how the engineers would learn to do that today. The problem is, when I come around here, I don't know that tangency point, and when I swing that arc to here, I don't know that tangency point either. And so I could go do some math help and try to figure it out. I could go upstairs to the engineer and say, hey, tell me this point. Or I could just rely on the ProtoTRAK to tell me how to do it. So I'm going to do a profile, and it's not a circle or a rectangle, it's an irregular profile. And I don't want to start on the edge of the part. I'd like to start off the piece so I can ramp on with an arc or a mill. I'm going to simply start with a mill off the piece and go over to the top of my arc. So I'm going to start -3 inches away in X, 2.45, because that's the radius of the big arc. We'll leave my default there. We'll come down to the depth. I'm going to put the cutter on the left to climb mill. I've got a default for my depth of path, which is fine. I'll accept the finish cut. And you know what? I like my spindle speeds and feeds from before. I'm just going to carry all that over. And it shows you right now that there's my starting point. Well, I got two choices, straight line or curved line. I'm going to do a straight line or a mill. I'm going to come right over to 0 and X, and I'm going to be still at 2.45 ab set, or incrementally I don't change, one button. There are more choices here. I'm going to simply skip it. Now I'm here, now I want to swing that arc. That's an arc. It says, hey, is that arc tangent to the previous line? The answer is yeah. What direction am I going? I'm going clockwise. Where does X end? Well, X is going to end still at absolute 0. Y is going to end down at -2.45, the radius of my arc. My center is 0, 0. And with that, it says it's okay. There's still more questions, but you know what? I don't have to answer them. Now I'm here. Now I want to mill out here. And the problem is, looking at that drawing, I don't know where that line is going to stop. But I'm going to mill. I'm going to tell it's not tangent. And looking at the X and Y, I'm going to press the button here that says guess. I'm going to say, I think it comes out to right about here. And I'm going to enter that as my guess dimension. And it dots the line to show me the direction that it's intending to go. But because I'm not putting in an X or a Y and I don't know the length and I don't know the angle, I'm going to skip those questions and it's going to leave that event not okay and dotted. But you know what? If I tell it more information, it should figure it out. So now I want to do that 841 radius arc. It happens to be tangent to the previous line. It's going around clockwise. And it's going to end up here somewhere. And once again, I don't know that, so I'm going to just guess it. It's right about there, and I'm going to enter that. I'm going to put in the center. The center of X is minus 1.711. The Y center of that 841 radius is 0.368. The radius is 0.841. And you know what, it's saying it's not okay, and it's really not figured out where I want to go. I see that I've made a mistake here. I can simply jump right back up. And I can see that the line and arc are sort of out there, but they're not quite right. But let's tell it some more information. Maybe it can figure it. I want to do a straight line. That straight line is tangent. It's going to end up here at the top of the arc, which was 0 and 2.45. And with that, it went back and back figured your points and saved you having to do any math help or ask an engineer for help. If I'd like to ramp off the top of the part, I'm simply going to tell it that I want to do another mill event. I'm going to let it be tangent. I don't know the X or Y. I'm going to skip all that. I'm going to tell it I want to go about 1/2 inch. And now I'm going to put in the line angle, and you're saying, well, you know, it's not on the drawing. How do I know that? Well, it's the same as the line angle right there, which is 32.402. And with that, I now have a nice, smooth ramp off for my part. I've put the tools in. Let's hit setup. Tool path shows me how it's going to machine the part and tells me that the run time for that is 2 minutes and 38 seconds. Let's take you one step further. What if I could bring in a DXF file? If I look at this, I have some borders and some dimension lines that could get in the way, but they don't bother me. Most DXF converters, the manufacturer is going to tell you you have to start with a clean file. So strip out any unwanted layers. We don't force you to do that. If the engineer or the draftsman happen to draw everything in one layer, I can still work around it, not a problem. But I do have the ability to come here and turn off anything I don't want to see so that I can just focus on the part. Continue. Line gaps. Most drawings today are done in solid models, but people want DXF files, so they have to take a solid model, which is one type of software, and convert to DXF, which is another. And when you go from one software to another, oftentimes you can have problems. So the first thing that a person needs to do after the conversion is go back and trim their lines. They got to make sure that there's no gaps or overlaps, because a gap of 1/1000 will stop a CNC machine. We put a line gap tolerance of 5/1000, so we'll auto trim to 5/1000 for you. So if somebody has skipped that step, we're going to go ahead and do that work. I got the ability to rotate the part around because they may not have drawn it on the drawing the same way you want to hold it on the table. I can decide where I want the 0 to be. Maybe from an engineering standpoint, it made sense to dimension this from that tangency point out in space. But in looking at the part and how it's going to sit on the table, I'd really like to work from the middle, so I'm going to tell it I'm going to work from the center. And this is where I'm going to program from, regardless of how it's been drawn. add a line, add a point. Well, remember we just did this manually by entering the data, and we talked about having the ability to ramp on. Well, other DXF converters don't give you a ramp on, ramp up option. You got to go program the geometry, get the program written, and then go edit your program. I'm going to let you click on new point. I can touch on a piece of geometry, come out in space and click on a new point, and I've just created a ramp on. And I'm going to click on a piece of geometry and come up here, and there's my ramp off. Let's drill some holes. Well, there's no can cycle for, or G-code can cycle for bolt circles. So I have a 5-hole bolt hole pattern, which we just showed is pretty easy to do. But imagine this being 50 random holes. I can tell it I want to start drilling holes, and I can come in here with my finger and start clicking on the holes in the order that I want to go. And once I get to the last hole, I go to my event tab and I fill in the missing information. It's a flat drawing. It can get all the X and Y, but it doesn't know where I want to wrap it to. It doesn't know how deep to go. It doesn't know if I need any PEX. It doesn't know what my spindle speed should be, nor does it know what feed rate I should use for the material or the tool number that I want. But once I selected that, whether it's 5 holes, 50 holes, 100 holes, it would all be programmed for you. I have a circle pocket in the middle we just programmed, but maybe that's a through hole and it's already in the part, and I'm going to set this up by tramming that bore. And so I don't need that geometry to be in my CNC program, so I'm just not going to bother to select it. But I do want to do that profile. So I'm going to click on profile, and it says, do you want a chain? And I'm going to say yes. This is a question from the AutoCAD manual back in the 90s. Chaining says if you got a line and or an arc that intersect, you can chain them together and not have to enter all the geometry. So I said I want a chain. I'm going to start out here, and then I'm going to go to there, and it chains and picks up all the geometry of my ballpark. And I go to the event tab. It knows X and Y. Here's my rapid. Here's my depth. Depth of pass, finish cut. Yeah, let's give it some spindle speed. Let's give it some feed rate. Tool number. And so once again, I've programmed the ballpark. This time I use DXF as opposed to manually inputting all the data. But it allows me to get to making and machining the part on a machine very quickly. In a day where we suffer across the country with a lack of skilled machinists, and oftentimes our best and most expensive people are also the ones that have to control and run our 4 and 5 axis machine centers. Why not take basic flat work that's 2.5 axis and let somebody do it very quickly right at the control? So I can program at the control. I can bring in a DXF, but I can also bring in a Parasolid. And if you're not familiar with the term Parasolid, Parasolid is the basis for all solid modeling. And for quite some time now, we've allowed you to bring a solid right into the ProtoTRAK. Now it's going to be 2.5 axis milling, it's not 3 axis. I'm going to say, hey, I want to work from the top of the part here. I'm going to rotate it around because this is maybe how I want to fixture it on the table. I'm going to keep on going. You're going to notice that it follows a format an awful lot like DXF. Most people buy the combo pack that gives you DXF for old style drawings, Parasolid for modern drawings. If I want to work from the upper left hand corner, I'm going to work at the intersection of those 2 lines. I'd like to ramp on and ramp off just like we did before, so let's extend that line this way and extend this line that way. I want to drill some holes. Once again, using my finger, I'm going to go pick on the holes in the order that I want to go. I'm going to come up to my event tab, and I have to enter in the Z stuff. Where to rapid the tool. Well, now I want to go to depth. If I say view solid, I can take my part, I can flip it around, touch on the back, and say width offset, and it enters a dimension of 1 inch 162. Well, it knows the part's 1 inch thick. It knows that I want to go at least 30 thousandths past that 1 inch to clear it. And then it takes the diameter of the hole, it calculates the 118-degree drill point angle, and so it's telling me for that size hole, I got to go 1 inch 162 thousandths through the part to clear the tool, and I didn't have to do any calculating. Give it some spindle speed, give it some feed rate, give it a tool number. Exit solid, back to programming. You want to do that outside profile? Once again, do you want a chain? Going to start over here. Going to start here. And go here. Let's undo that mess. Once again, let's go view the solid. I'm going to keep that same rapid. I'm going to tap on the top back bar of my part again and say with offset. Remember I told you it was 1 inch thick and it wanted to go 30 thousandths past. It's done that calculating for me. I put in depth of pass, give it the same spindle speeds, some feed rate. Tool number. And with that, I have the ability to continue along programming my part. Going to follow the same format as it did with DXF, but now I'm working from the solid. And one of the beautiful things about having the solid available is we've all walked out or through a shop and seen 3 people standing there staring at a blueprint, trying to figure out what the engineer's trying to communicate. But if you had the part in your hand, you would know right away. Well, if I have a question like that, because I have the solid model right there, I can go flip it around, rotate around, and save that time of asking my buddy for help, because the help is right there with the part itself. So I can program by entering the info. I can bring in a DXF to streamline my programming. I can bring in a solid to streamline my programming. Or if it's a 3D surface or something highly complicated, I can bring in a CAM file and just run the straight G code. And I'm doing that all with the same control and the same mill on a ProtoTRAK. Before we go away, let's talk about a couple other features that you might find useful with a ProtoTRAK. One is Engrave. So we've been able to engrave for 25 years, but engraving always started with the bottom left-hand corner of the first word. So if I told it that I wanted to start at 0 and plus 1 inch and wrap it down some amount and maybe go 30 thousandths deep, and I tell it that my letters are going to be 3/4 of an inch tall. Text, I can pull up my keyboard and I can type in whatever I would like to program. Let's go with PROTOTRAK to pick some random word. Put my keyboard away, hit set, give it some spindle speed, give it some feed rate, and a tool number. And with that, there's ProtoTRAK, and you can notice that it's centered itself. It's not at the bottom left-hand corner. If I come back and look at the event, I go look at my options, I have choices. I have my default set to go off the center. If I still wanted to work from that lower left-hand corner, well, that still works the way that it used to. And what's even really cool now is I can come back in here and I can tell it that I want to work from the center. I can change it from being horizontal to vertical, which I couldn't do before. Or I can come back and say I want to do radial, and notice it asks for a couple other questions. It wants to know what radius I want to work off of, and it wants to know an angle to start at, and now it's taken and wrapped that around a circle. So I've had Engrave before, but it was just linear, and it started bottom left-hand corner. I still have Engrave. It's the same ease of use, but I've got far more choices. So that's some of the features of the newer ProtoTRAK. It's not your father's ProtoTRAK. Any questions? If you have them, contact your local ProtoTRAK rep. We'll be glad to help.